Here we are going to learn the general term. First we'll understand the general term and then we'll see how it can be applied to different questions. So the general term in the binomial, like if you have binomial say a plus b raised to n, then its general term is given by NCR a raised to n minus r into b raised to r. Here we need to understand that a is the first term from the binomial, which we can see here. B, the second term, with its sign we have to keep. If it is minus in between, then we have to keep minus inside the bracket, and whole raised to r we have to write in the general term. After writing the general term, it is very important to understand the values of r. Why it is called general term? Why it is called general term? Because it generates all the required terms. Right, if we put r is equal to suppose say 0, it will give you the first term. If r is equal to 1, it will give me the second term. R is equal to 2, it will give me the third term. If I put 3, it will give me the fourth term, and so on. And the last maximum value of r I can keep is n. So if I keep n instead of r, it will give me the n plus 1, or we can say the last term of the binomial expansion. So total we know there are n plus 1 terms are there in the binomial, and the order of this term is r plus 1. The general term is denoted by t r plus 1 is equal to n c r a raised to n minus r b raised to r. This is the general term, and the values of r is the same. If you keep r is equal to 0 here, then it's 0 plus 1, it will give me the first term. If r is 1 over here again, then it will give me the second term. If you put r is equal to 2, it will give me capital T3. 2 plus 1 is 3, so it's a third term, and so on. If I keep the last value instead of r n, then it will give me n plus 1 term. So this is the general term. This we are going to use in different questions. Now let us see the first question based on the general term, or using the general term. The question is something like this. I write number 1, A part. The question is 1 plus 2x raised to it's 11, and I want to find the first 3 terms and last 2 terms as per the question. Now first 3 terms I would like to find, so I am going for the general term formula, and in general term formula I am going to keep different values of r to get different terms. So in general term formula, if I keep r is equal to 0, I'll get the first term, right? So r is equal to 0, so it's going to be t1, and in formula, above formula in green color you can see is n c 0 a raised to n minus 0 b raised to 0. N minus 0 is n, so power of a is n. Now I keep different values. If I compare this with the general term, I am having a yani कि first term, that I am having 1, b the second term, that is 2x, and power, that is n is equal to 11. I keep these values in the first term to get the first term. Instead of n, I am going to keep 11. So 11 is 0, a, that is 1 raised to n minus 0, that's 11 minus 0, 11 you can say. Instead of b, I am keeping 2x raised to 0. Now we know the different values of this 11c0 by calculator or any means at the formula, you can go, you're going to get 1. 1 raised to 11 is 1, and 2x raised to 0 is also 1. So 1 into 1 into 1, I'm going to get first term as 1. Now if I keep r is equal to 1 in order to get the second term in the general term formula, so t2 I am going to get again uh, n c, instead of r I am keeping 1 here, a raised to, power of a is always the n minus r, so n is n and r is 1, so n minus 1, and b raised to is going to be r is 1 over here, so I'm keeping 1 power. Now keeping value of keeping value of a, b and n in this case, a, b, n value, I'm going to get 11 c 1, 1 raised to 11 minus 1, that is 10, 2x raised to r is 1. Now if you simplify, 11c1 is 11, 1 raised to any power is 1, and 2x as 1 power is 2x. So if you simplify this, or if you multiply all constants, is going to get 22, and x is in multiplication, so 22x. Similarly, if you keep r is equal to 2 in this case, you'll get the third term t3. T3 is n c 2, because r you are keeping 2 to get the third term in the general term formula. A raised to n minus 2, b raised to 2. Now n is 11 c 2, 1 raised to 11 c2, 1 raised to 11 minus 2, that is going to be 9, and 2x raised to, here I'm going to get 2x raised to 2 r, that is 2 power. Now 11c2, if you use calculator, we are going to get 55, 1 raised to 9 is 1, and 2x all raised to 2, so 2 will get 2 power, that is 4, and x also will get 2 power, so x square. So that way if you multiply, it's going to be 220 x square. This is what the third term in the binomial expansion. These are the first three terms. We can see in the symbol we are getting first three terms in the binomial expansion. Why it is first three terms? Because we keep r is equal to, we can see here, we keep r is equal to 0, 1 and 2 to get t1 here, t2 and t3. So first three terms we got. Now we are going for another two terms from the end they are talking about. Now see, possible values of r in this case is, what are the possible values? We keep 0, 1, 2. R values always in the general term formula, if you look at it above, r is always starts begin with 0 in the general term formula. If you see, begin with 0, it goes 1, 2, all integers, and last value of r is n, and in our example n is 11. So the possible values of r are 0, 1, 2, 3, it can be 3, 4, dot 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 dot, it goes till 11. Possible values of r are till 11. Okay, now last two terms we want. So what are the values we keep for r are 10 and 11, because 11 is the last number and the second last number is 10. So if we put r is equal to 10 and 11, we'll get the last two terms in the binomial expansion. So we keep r is equal to 10 and r is equal to 11 to get the last two terms. I am using green color to write this. So r is equal to, I am keeping 10. Now when you keep r is equal to 10 in the general term formula, it's going to be 10 plus 1, that is 11 NCR a raised to n minus r, n minus 10, and b raised to 10 is equal to n. N is 11. I'm keeping value of n, a and b. So 11 c 10, a is 1, 1 has 11 minus 10, n is 11, so 11 minus 10 is 1. 2x raised to r, r is 10. So if you simplify 11c 10 is going to be 11. 1 raised to any power is 1, and 2 raised to 10 is 1024, because 2 and x both of them are going to get power 10 because its power is outside the bracket. So 2 raised to 10 is 1024, and x raised to 10 is x raised to 10. If you little simplify this, you are going to get here is you need to do is all 1024 into 11. So 1024 into 11 will give you 11, will give you 11,264 x raised to 10. This is what you are going to get, the second last term, right? That is what the answer for this. Now moving further, we wanted last two terms, so second last term I got. Now I'm going for the last term, so you have to keep obviously r is equal to what? 11. So r is equal to 11, so it's going to get t. 11 plus 1 is 12. 12 is the last term, 12 term. nc 11, a raised to n minus 11, b raised to 11. So if we keep these values, it's 11c 11, 1 raised to n minus 11, n is 11, 11 minus 11 is 0, 2x raised to r is 11, is equal to 11c 11 is 1, 1 raised to 0 is 1, and 2 raised to 11 is 2048 into x raised to 11. So my final answer for this is 2048. Yeah, is 2048 into x raised to 11. So we got finally all required terms, first three terms and last two terms in the binomial expansion of 1 plus 2x. It is this 1 plus 2x, 1 plus 2x raised to 11. This was the question 1a. Now moving further, question about, suppose say 1b. So in 1b I say is question number 1b is against the again the same. You need to write the first three terms in the binomial expansion and last two terms of the binomial expansion. So it is this all raised to, it is 15. Yeah, so this is a question. Now I need to write first three terms, so I go for what are the values of a, b and n. You have to decide. A is the first term inside the bracket, that is we are having 3x. B is the second term, that is 2x positive, so no need to write plus there, and power is n is equal to 15. I write that. Now to get the first three terms, I'll keep putting r is equal to 0, r is equal to 1, and r is equal to 2. Okay, so now we keep this in the formula. General term formula is going to be nc0 a raised to n minus r, that is n minus 0, and b raised to 0 is equal to n is 15, c0, a is 3x raised to, I keep 3x in the bracket because whole is having a is having power n, so a is 3x, so whole is having 15 power, and b is 2 by x raised to 0 power. Now 15c0 is easy to get 1. Now 3 and x both will get 15 power, so I write 3 raised to 15 into x raised to 15. All terms are in multiplication, and 2 upon x all raised to 0 power, there is going to be 1. So final answer is 3 raised to 15 and x raised to 3 raised to 15 into x raised to 15. I will leave as it is. 3 raised to 15 is going to be big number. You can use calculator if you want to write. Now r is equal to 1 if you keep is going to be nc1 a raised to n minus 1, that is n minus r. N minus r is n minus 1 because r is 1, and b raised to r, that is 1. So keep this value of n is 15 c1 a for our case is 3x raised to 15 minus 1, that is 14, 2 by x raised to r is 1. Okay, 15 c1 is 15 into 3 raised to 14 into x raised to 14 into 2 raised to 1 is 2 upon x raised to 1 is x, also you can write. Now with this we can simplify. We can multiply all constants. So where are the constants? If you look at it, this question, we have constants over here. There is 15, 3 and 2. This all three constants gets multiplied and it will give you 15 into 2 into, I write in the row form only, 3 raised to 14 into, now terms having x power, there are two terms, one in numerator and one in denominator. They are left to simplify. X raised to 14 upon x raised to 1, that is going to be, by laws of indices, x raised to 14 minus 1, that is x raised to 13. You can write x raised to 13. Further, if you want to simplify, you have to use calculator. 15 to the 30 into 3 raised to 14 into x raised to 13. This is going to be a second term in the binomial expansion. Okay, now further moving for the third term from the beginning in the binomial expansion is n, by keeping r is equal to is nc 2 a raised to n minus r, but is r is 2, so n minus 2 b raised to 2 is equal to 15c2 3x, a is 3x raised to n minus r, that is 15 minus 2 because r is 2, so 15 minus 2 will give me 13 and 2 by x raised to is going to be 2 power. Simplify further, 15c2 is going to be, if you use calculator, 15c2 will give me is 105 into, now this 3 and x both will get power, so 3 raised to 13 into x raised to 13, they are all in multiplication only, into 2 by x whole raised to 2, so 2 will get 2 power, that is 4, and x will also get 2 power in denominator, it is this. Further simplifying this, I'm getting all constants together. So constants are 105 into 3 raised to 13 into 2 raised to 2, this is 13, 3 into 2 raised to 2, that is 4. Now terms having base x, one in numerator, one in denominator, x raised to 13 upon x raised to 2, that is going to be x raised to 13 minus 2, that is x raised to 13 minus 2, that is 11, and this is by laws of indices. Now this product you can work out through calculator and you can write the final term over here. Moving ahead, last two terms we want. So what we have to keep is n is here 15, so we can understand maximum value of r is 15. So r, if you keep 14, you'll get 15 term, and there are 16 terms total in the expansion. If you keep r is equal to 14, you'll get the second last term, and r is equal to, if you keep 15, you'll get the last term in the expansion. So n c 14, in general term I am keeping a raised to n minus r 14, b raised to 14, and if you give r is equal to 15 here, this term is going to be n c 15 a raised to n minus 15 b raised to 15 is equal to, now give these values, n is 15, c 14, a is 3x raised to n minus r, so 15 minus 14 is 1, and 2 by x, they are going to get power r, that is 14 power. Simplifying further, 15 c 14, if you put in calculator, is going to be 15. 3 and x both will get 1 power, that is 3x itself, and 2 raised to 14 in numerator, and in denominator it is x raised to 14. Yeah. Now what we can simplify is this constants. The constants are 15 into 3 into they are going to be one more term, that is 2 raised to 15 into 3 into 2 raised to 14 into, now there are two terms left which are having x power. So one in the numerator, that is x raised to 1, and one in the denominator, that is x raised to 14. Now if you simplify this power by laws of indices, if you take in numerator, is going to be x raised to 1 minus 14, 1 minus 14, because numerator is having 1 power, denominator is having 14 power. By laws of indices is going to be 1 minus 14 in numerator. Now this little further, if you want, you can simplify, use your calculator. 45 into 2 raised to 14 into x raised to minus 30. Yeah, so this can be worked out using calculator, and this will be the required second last term in the expansion. Now we are going for the last term, that is 15 c 15, n is 15, so a raised to n minus r, is 15 minus 15, 0 power, and b, that is 2 by x raised to r is 15 power over here. Further simplifying, 15 c 15 is going to be 1, 3x as 0 power is 1 again, and 2 as 15 power, and denominator x is also having 15 power. If you simplify further, the constant in the numerator is going to be 2 raised to 15 into 1, that is 1. No need to write that in multiplication. And in denominator we have x raised to 15. If you bring in numerator, is going to be x raised to minus 15, or you can leave in denominator, that is also fine with positive power. So this way we can write the different terms, required terms, as per the question.